All right, we'll real quickly just go back over this. So we had the function s. So we had the function s, which was our position function, and s prime would be our velocity function, and speed is our absolute value of velocity. And so in order to figure out the total distance traveled from 0 to 5, we'd integrate from 0 to 5 the absolute value of our speed function. So let's see, somebody was at, why isn't A also correct? Which is s of 0 plus the integral from 0 to 2 of s prime minus the integral from 2 to 5 of s prime. A is not correct because A includes the initial position, and the initial position has absolutely nothing to do with the distance we traveled. This right there indicates the total distance that we traveled, because 0 to 2 we know is positive for s prime, and we know that 2 to 5 was negative, so the opposite of that would make this positive. So this is the distance traveled. But this is our initial position, which has nothing to do with how far we traveled, how far we went. Does that make sense? Conceptually, D, the absolute value of, D has no conceptual meaning whatsoever with relation to any sort of particle motion. It's just some garbage they put there to hope that you'd put the absolute value in the wrong place and get it wrong. So, and then C looks close to right, but C has got the negative on the 0 to 2 and the positive there. This would give us the opposite of the total distance traveled. So, all right, let's see if that answers everybody's questions on that. Oh, cool. But I lost the chat on that last meeting there. Let me see if, I think it should be in here. Should be able to look at it. No, I can't look at the chat until it finishes recording the meeting, which it's not done doing yet. Can't look at the old chat. I don't know. Whoever asked for number 80 here, whichever one that was, did you ask for anything else after that? I'll be able to look at the chat in a second, but right now I can't see the chat from the first half of our class. Okay. Yeah. I'll just go with what's in the chat here currently, and then once I get the other one, I'll go back to those. So we're looking at 88 now from 2012. I did not want a duplicate page. That's not what I wanted. I wanted to take a picture of this street light. All right, we got a person, 6 feet, walking away from the base of the street light. We want to know what is the rate at which the person's shadow is lengthening. So we can, we can do this. Pretend like I drew that really nicely. There's our person. There's our street lamp. There you go. Now it looks really nice. That looks like I did an amazing job drawing that. What do we have here? We have two similar triangles, right angle, and they share that angle in common. We're interested in what rate is this thing changing. We'll call that x. And let's call this distance y. And so we want to know how is x changing. Well, we know what dy dt is, right? We know how fast the person is walking, 4 feet per second. And we should be able to relate the height of the person, the height of the street light, and x and y using similar triangles. X over 6 should be equal to x plus y over 15. And we could rewrite this if we wanted as x over 6 equals x over 15 plus y over 15. And that would make this even easier. Because now the derivative of 1/6 x is just 1/6 dx dt. And this is 1/15 dx dt. And this is 1 plus 1/15 dy dt. And we're just looking for dy. No, we're looking for dx dt. So 1/16 minus 1/15. And what does that come out to be? We got to get a common denominator there. That should what is that, 30? Yeah, that'd be the best thing there. So we got 5 over 30 minus 2 over 30. So we got 3 over 30. Is that right? 5 times 2, yeah, 3 over 30. Okay, yeah, 3 over 30. Dx dt equals 1/15 of 4. This is 1/10. Multiply by 10, we end up with dx dt equals 40 over 15. Divide those both by 5, and you get 8/3. And 8/3 is 2.667. Good there? Now, any questions there on that one? All right. We got 91 and 92 from 2013. Watch this. You guys are going to be really impressed here. Look at that. I put them both on the same page. We can do 2 problems at once without me having to go and screen clip them. It's very impressive. All right. We've got the function f is continuous, and the integral from 0 to 8 of f of u du equals 6. What is the value of the integral from 1 to 3 of x f of x squared minus 1? Well, this one, obviously, we're not going to be able to integrate x f of x squared minus 1 dx how it sits. But what we could do is we could let u equal x squared minus 1, and then du would be 2x dx, which would mean we'd need to put in a 1/2 and a 2. And then we could do a u substitution and get 1/2 of the integral of 2x dx is my du, and this just becomes f of u du. So 1/2 of the integral of f of u du. If I plug in 1 to x here, I get 0. And if I plug in 3, I get 8. So it's 1/2 of the integral from 0 to 8 of f of u du is what this is equivalent to. And the integral from 0 to 8 is 6. So half of the integral from 0 to 8 ought to be 3. Any questions there on 91? All right, 92, f is defined for all x in this interval, but f does not attain a maximum on the closed interval from a to b. So let's just sort of eliminate something. So this seems like it's a little bit contradictory to what we know. Normally, if we have a closed interval, it has to attain a maximum value, right? But if we had, let's see, let's start at the bottom here. The equation f prime of x equals 0 does not have a solution. So saying that there's no critical values, well, we're on a closed interval, so we're going to get a max if we just, I mean, even if there's no places where my derivative is 0, that doesn't make a lot of sense. If our function is defined for all x in the interval from a to b, there's not going to be a vertical asymptote. That doesn't make any sense. It says f does not attain a minimum value on a to b. Well, just because it doesn't have a max doesn't mean that it's not, doesn't mean that it doesn't have a min. So that doesn't make sense. F not being bounded would mean that like it's increasing forever. But if it's increasing forever so quickly that we don't ever actually get to B, that wouldn't make any sense, or to A. So the only option is that it's not continuous on A to B. And so that is our only choice. And that follows from the extreme value theorem, because the extreme value theorem says that if F is continuous on A to B, there will be a max. So if there is not a max and a min, if there is not necessarily a max or a min, the function must not be continuous on the interval from A to B. It could still be defined everywhere, but no max, no min. Example of a graph that could look like that would be, here's A, here's B, I start here, I have this, but right here I have this and this. And so my function is defined for all values between A and B. And it's defined at A, it's defined at B, and it's defined for everything between A and B. But I don't hit a max value at all, right? Or in fact, in this case, I also don't hit a min, but I could if I wanted to. If we get rid of this, this would make sense. Oh, that was not what I meant to do. Right now, this is one that does contain a minimum, right? Not one with a minimum, but it still doesn't contain a maximum. Does that make sense to everybody?
Wait, wouldn't the max just be the point right next to like the blank dot? Like it'd be directly left?
What's that point?
Sorry, you cut out a little.
So what's that point? What's the point right next to the open circle? You're talking about this point?
No, like if there's a hole in there, like where it's supposed to be the max, wouldn't the max just be the place right next to it, like
right
directly left?
So no, I'm trying to ask you, what is the point right next to this point? What x value? Suppose b equals 2. And a is -2. What's the point right next to b equals 2, where we're at a max? What's the x value?
Something really close to 2, like 1.9?
1.9. Well, I would contend that the value at 1.9 is not the max, because I could find the value at 1.99, which should be bigger than the value at 1.9.
Right.
Well, what about okay, well, what about 1.99? Well, I could find the value at 1.999. That's going to be higher than the value at 1.99. And the value at 1.999 is going to certainly be less than the value at 1.9999999999999, which is going to be less than the value at 1.9999999999999, which is going to be less than the value, and so on. Right? I'm never going to get to a highest value. It keeps getting closer and closer and closer and closer. It keeps getting larger and larger and larger, but it doesn't actually get to a value there. So there is no max. Does that make sense?
Yeah, thanks.
Mm-hmm.
Wait, why doesn't the vertical asymptote make sense?
If you have a vertical asymptote, then the function isn't defined on the interval.
Ah, okay, that makes sense.
Yeah. Any other questions there on that one? All right. I think, let me see here real quick. I'm trying to check in this. The old chat here, 91, 92. And then 3D and 4 on the non-3D 4A, which I think is now written here. Just Ignore me mumbling to myself. All right, I think we just got a couple more. That people have asked for. So we're going to do a couple of the free response parts. Now I forgot what, 2013. All right, 3D from 2013. Maybe. I probably need multiple things here. Give me 1 second. That's not what I meant to do. All right, here is 3 and just the basic information from 3. And then we also need 3 part D. That's what is being asked for. All right, here's 3D. So let's see if we can do this without parts A, B, and C. Otherwise, I'm gonna have to go back and look at those little. So we're given, let's see, we're given a chart. This is a twice differentiable function of W. We're given the chart of W prime, gigaliters per day. And we have an initial condition. Then we have an equation, A equals 0.3 W to the 2/3 is the relationship between the area A on the surface of the reservoir and the volume of water. Find the instantaneous rate of change of A with respect to T when T equals 30 days. Okay. Let me think about this for a second. Let me go back and I gotta go back and look at the actual problem and see if there's some other information in here real quick that we're gonna need. Yeah, no, yeah, it doesn't seem like it. All right, I think we should be good. So I think we're fine here. In order to find this, we're looking for the rate of change with respect to t. So this is basically like we're taking the derivative of a with respect to t. That's what we want. So we got to take the derivative of both sides of it with respect to t. So dA dt needs to equal the derivative of 0.3 times W to the 2/3 ought to be 0.6 over 3 W to the negative 1/3 dW dt. And I think, I know we're talking about when t equals 30. At t equals 30, dW dt ought to be the derivative of W, ought to be 1/2. So, and let's see, at t equals 30, the reservoir has 125 gigaliters of water, so W is 125. So we should be looking at 0.6 divided by 3, which is 0.2. And then W to the negative 1/3 should be the cube root of 125 in the denominator, and then a 2 right here. So this is really just going to be 0.1 over 5. Or if I multiply this by 10, it looks like it should come out to be 1 over 50 kilometers squared per day. Good or no?
Good.
Yep, just take the derivative with respect to t, plug in all your values, just a little related rate thing. All right, and then let's see here. Somebody wanted 4A. Let's see here. There it is. So these limits here. We're given x squared minus 2x minus 1 times e to the x. Find the limit as x approaches infinity. Well, as x approaches infinity, this is infinity times infinity. Well, a big number times another big number is a big number, infinity. Or you could state that that doesn't exist. Either one would probably be an acceptable answer. Well, guaranteed either one would be an acceptable answer. But as we go towards negative infinity, this ends up being x squared minus 2x minus 1 over e to the x, right? That's like taking this limit as x approaches infinity. So we end up with the numerator is increasing more slowly than the denominator. The denominator is getting larger more quickly. So like we talked about, I think with the very first problem we did today, if the denominator increases more rapidly than the numerator, it goes towards 0. Any questions there? I think that's everything that anybody has asked for, unless I missed something. Anybody have any other questions?